Okay, we are picking up from where we left off, continuing to talk about quantitative data analysis. To be clear, most of what we're focusing on is descriptive statistics, but a little bit of inferential statistics as well. And descriptive statistics refers to statistics to summarize overall patterns in the data, looking at measures of central tendency, frequency distributions, variability. Whereas inferential statistics is looking at more than one variable at a time and making inferences to a population. So we will be focusing on looking at correlations. So a correlation, which has come up sort of when we've been talking about research in general, but now we're kind of talking a bit more about what it means in terms of statistics. We can define a correlation coefficient as the strength of the predictive relationship between two variables. And to accurately use correlations, we're only looking at what's called continuous variables, which tend to be ordinal or interval ratio. And we're interested in both positive correlations, which would be in a coefficient between 0 and 1, and negative relationships, coefficient between 0 and negative 1. And again, this relationship between x and y, or the independent and dependent variable. Very important to note, correlation does not mean causation. We're going to talk about causation in a few slides. There is a rule of thumb in terms of how big a correlation is. 0.10 or less, either positive or negative, is considered small. 0.1 to 0.3 is considered moderate, and 0.5 or greater is considered large. Again, both on the positive and the negative end. Okay, so this is very important. We're talking about a positive correlation. That means that as one variable increases, the other also increases. So as the independent variable increases, the dependent variable also increases. However, it also means that as one decreases, the other decreases. So positive just means that they're moving in the same direction. For example, if you hear that a study found a positive correlation between years of education and income, that would indicate that the more years of education you have, the higher your income, but also the opposite. Fewer years of education, lower income. This is different than a negative correlation, where the variables are moving in opposite directions. So as one goes up, the other goes down, or vice versa. I wrote this the same way, but as one variable decreases, the other increases, or as one variable increases, the other decreases. It's a little bit of a typo there. So let's say a study found a negative correlation between hours spent exercising and BMI. BMI is a measure of obesity. So that would mean, a negative correlation means that those who exercise for more hours had a lower BMI. Those who exercise for fewer hours had a higher BMI. I like to think of it sometimes as an arrow. Negative correlation is one arrow goes up, one arrow goes down. Okay. Already talked about this, so you might also see this graphically. So this figure is looking at different states, the percentage of residents in the state that have a bachelor's degree, and the median, as opposed to the mean, household income. So similar to one of the examples I had before. And if we're able to draw like a line that connects these different data points, these different states, we can see that it's positive, right? As income goes up, education goes up, and vice versa. And the other thing to note with correlations, even though we're really interested in what's the independent and what's the dependent variable, correlation means it can go both ways. As one goes up, in this case with positive correlation, as one goes up, the other goes up as well. You might also see correlations a different way. And I know this is a lot to look at once, but this is something called a correlation matrix. Okay. And so it's providing us with the actual correlation coefficients. So let's just focus on this one. Okay. So a correlation of 0.53, it's positive and it's pretty big. It's bigger than 0.5. And I'll tell you that the variables here, so the way we read this is we go and we see what is the row, okay, education. What's the column? Okay, it's something called PA education. So what this means is this is a survey asking people, what is your level of education and what is your father's, PA, right? Paternal education. What is your father's level of education? So this is saying that they found that for people, the more education they had, the more education their father had, and vice versa. Probably won't be surprised to see that Ma education is maternal education, and they also found a pretty strong correlation. The more education the person in the survey had, they also reported that their mothers had a lot of education too. The other interesting thing to note about a correlation matrix is that this diagonal is a 1. Right? Okay, let's see what's the row and what's the column. Oh, it's the same variable, right? So that's meaningless, right? Education correlation with itself is always going to be a perfect correlation. But it's interesting to note that I could have just shown you the right side, the right of the diagonal, because it's the same exact information. This coefficient of 0.53 is this coefficient of 0.53, because if we check out the row and the column, it's the same variables. Right? Some of the variables in here are negative. So here's an interesting one, negative 0.2. So that means there's a negative correlation. So it's small, or it's moderate rather, or it's small. So this means that this is work hours. How many hours did you work last week? What's your level of education? And they found that people that worked more hours tended to have lower education, but again, it's a small correlation. Or the opposite, right? People that worked fewer hours tended to have more education, because it's a negative correlation, has that negative sign in front of it. Okay, so correlation is prediction, right? We think that there's a relationship between these two variables, but it doesn't mean the same thing, that it's causing it, right? We're not saying that your education causes your father's education or vice versa. In order to get it cause and effect, which is difficult to use, difficult to do in research, and I would encourage you really to, when you use that word cause, X causes Y, that means something very specific. So don't use that strong language unless it really is the case. So in order to get it cause and effect, there needs to be a time order relationship. You need all three of these things. X has to come before Y in time. You need a correlation, okay? It's necessary, but it's not enough. And probably the most important and the most difficult one is it can't be explained by other factors. Okay. So let's say, this is sort of a classic example. They found a positive correlation between ice cream sales and crime. More ice cream sold, the more crime. Does that mean that ice cream sales cause crime? So just on its face, that seems kind of silly. Imagine that we get a time order relationship. We say, okay, ice cream sales in June strongly correlated with crime in July. So the ice cream sales preceded the crime. But we would argue that we can't get at 3. Maybe there's something else going on, right? Can't be explained by other factors. And that would be that crime tends to be higher in the summertime. You could think about different reasons why that might be the case. And people tend to eat ice cream in the summertime as well, right? So it might not be that ice cream and ice cream causes crime, but that there's these other factors going on that we're not accounting for. All right, so we can't get at cause and effect with just correlation, but we can look at quite a few things. Okay, I'm going to skip that. So first of all, I want you to be able to look at this in terms of words. So If Ms. Jones finds the higher the price of soft drinks in her store, the less soft drinks she sells. So prices higher, actual drinks sold lower. Is this a positive or a negative relationship? Is this a positive or a negative correlation? So take a minute, pause here, look back at the notes, at your notes, look back at the slides. What is that? Which one is it? Okay, we're going to move on. It is, oh, I had it on the slide. This is a negative correlation, right? One's going up, the other's going down. Okay. Another example. A researcher found that as the amount of time children spent outside increased, the amount of time they focused in the classroom also increased. So both going up would be a positive relationship. So what can we say about this? Can we say that spending more time outside causes an increase in children's focus? Can we say that knowing the amount of outside time children experience allows prediction of focus time? Or can we say children should be outside most of the time? So once again, pause here, read through this. What do you think is the correct answer? Okay, so it is B. Correlation lets us use this term prediction. We can, hey, if we know how much time, if there's a really strong correlation, if we know how much time children are outside, we can predict how much time they're going to focus. But we don't know that it's causal. We don't have enough information to get it cause and effect. And for the third one, that's a normative statement. We're not interested in that in research. We're interested in things that we can test empirically and don't have a value judgment on them. Another example. Suppose a study shows there is a strong negative relationship between drug addiction and household income. If this is so, we may conclude what? So take a moment, pause here, read through the answers, and then I'll give you the answer. So here I'll give you the answer. So again, negative means one goes up, one goes down, right? So if yes, they have a drug addiction, then their income is lower. So D is incorrect because D is a positive relationship. A and B are incorrect because even though it doesn't use that word causation, it's getting at that. It's saying if we do this, then this will disappear, right? This causes this, which is not what we can get at. We can only get that there's a correlation. We can just get at prediction. And here's one last example for you. Take a moment to read through this, pause it, and see if you can get the correct answer. Okay. And this is very similar to the previous example, but this time it's a positive relationship. So we have to be careful at getting at language that sounds too causal. We cannot do that.